So I thought it'd be fun to do a little side-by-side comparison of the two clocks that I've made. Clock on the right is my pendulum clock that I built back in 2016. I made a video about that a long time ago, and it's been up for, I don't know, a few years at least. And the clock on the left is the one I built much more recently. And so what I like about them is they're both hybrid clocks. They're both a combination of electrical and mechanical. This one is timed by a pendulum, and you can see it swinging back there. And it actually uses, open it really quick. It's got an electromagnetic drive for the to push the pendulum, as you can see right there. It's also got some photo sensors up there to both trigger the coils as well as to count the swings. And it's got a whole bunch of counting circuits there that control the display. And this one is also electromechanical because it has a, as you can see, there's a mechanical pocket watch movement in there. And it uses a piezoelectric sensor to pick up the vibrations from the ticks. And I've actually got a spare here, like this. This is a very similar one, and you can see there's the piezoelectric sensor. It's just epoxy to the backside, and that's how it couples in the vibrations. And this one uses basically an identical setup on its pocket watch movement. And previously, when I made a video on this, everything was on the breadboard, and there were just, you know, really messy wires going everywhere. But now I've got everything cleaned up. I'll turn this thing around really quick. And so everything is much neater now. And so this actually, one of the things both these clocks have in common is neither of them uses a microcontroller or any code whatsoever. This thing actually uses a vintage alarm clock IC to drive the 7-segment display. That's right here. That's really common in like digital alarm clocks from the 70s. And then other than that, it's just got some circuitry that takes the ticking signals and does a little bit of digital signal processing to convert it into a usable timing signal for the clock. And then that little flashing LED is a 1 hertz counting signal. But anyways, that's what it looks like on the inside. And of course, since it's a pocket watch and it's spring driven, it has to be wound. So I've got a little winding key right there. So, I mean, every, once a day or so, I have to, take that key out and wind up the pocket watch because, it's driven by a spring because, it's it's an antique pocket watch movement. If the watch stops ticking, the clock stops running. And so also that you see that little the LED chaser on the outside, that's actually synchronized with the ticks. So the watch ticks 5 times per second. So that actually basically works as a seconds counter. So when you see it go up and down, it's 1 second up, 1 second down. So that's effectively how it counts seconds. But yeah, I mean, I'm really satisfied with this one right here. This thing's, I just really like the way it turned out. And I mean, I like this thing too. But I don't know, lately, I just kind of like this one a little more. Just something about it. But I appreciate them both because they're kind of in the same style, sort of like, like a digital retro steampunk sort of thing. But anyways, this is the first time I've ever kind of like shown them back to back against each other. So 2 different approaches for hybrid electromechanical clocks. Anyways, just thought I would share that really quick. Thanks for watching.